This video will talk about atomic mass. So the normal unit for mass is grams or maybe kilograms. But when dealing with subatomic particles like protons, neutrons, and electrons, and atoms and stuff like that, it becomes such a large unit that it's really unwieldy. So there was a new unit that was made called the atomic mass unit, or AMU. And an AMU is equal to 1/12 the mass of a neutral carbon atom, carbon 12 atom. It's kind of just, like an arbitrary measurement system, but there you go. That's what it is. And so one atomic mass unit is about worth the mass of a proton or a neutron. And you can see that the proton and neutron are actually slightly more massive than an atomic mass unit. And you'll see that the electron is way less massive. So when you're trying to get the mass of a specific atom, the electron number becomes unimportant because the mass is so small compared to the protons and neutrons. And because the proton and neutron mass is close to one atomic mass unit, it's kind of easy to tell by something's atomic mass what its mass number is. So, for example, the actual atomic mass of chlorine 35 is 34.968852. So it's, basically 35. You notice it's kind of weird because you would expect the number to be a little bit above 35 because the mass of a proton and neutron are both a little bit more than one atomic mass unit. The reason that it's actually a little bit less is for there's a good reason for it. It's called mass defect, and it has to do with the mass changing when things are bound together. We're not going to talk about it that much. You can kind of accept that this is actually legit. We didn't just make it up, and that it shouldn't freak you out. And notice in a periodic table, there will be one number for each element, which is supposed to be its atomic mass. And we know that because different atoms have different isotopes with different mass numbers, there's not really like one atomic mass that would really describe an element. So what we've done is we've calculated a weighted average of the masses of the isotopes that make up an element and used that to describe the quote-unquote mass of the element. And so a weighted average, remember, is just an average that counts more for things that are more abundant. And it doesn't even have to be abundant. So for example, your grades in my class are about 60% test, 20% homework, 20% lab. So if you do really well in labs, that'll have more of an effect on your grade than doing really well. If you do really well on tests, it'll have more effect on your grades than doing really well in lab or homework. And so the way that this is done is you just get the kind of percent abundance of each isotope and that isotope's atomic mass. And then you get the weighted average of those isotopes, and that'll give you the kind of average atomic mass for the element. So for chlorine here, and you should do this on your calculator just to check, the two kind of abundant isotopes of chlorine are chlorine 35 and chlorine 37. And I've written their atomic masses out here in AMUs. So if you get the weighted average of these numbers, you should get 35.453 AMUs, which is the number you'll see on a periodic table. So just to review the math really quick. For chlorine, that you would just be getting this number here. You're multiplying it by this number here, well, divided by 100. All right, we're going to make it into a fraction, plus this number times this number divided by 100. So that would be 34.968852 times 0.7577 plus 36.965903 times 0.2423. And that should give you 35.453. And I've given you another example here for silicon that you can do just to practice and make sure that you can come up with this number. And that's it.